Okay, so today we're going to go over limiting reactant and percent yield. A limiting reactant is the reactant that runs out first in a chemical reaction. So a real life example of this would be making a cake out of box cake mix. So you have your box mix, your vegetable oil, your eggs. So let's say we have 4 boxes of cake mix. Okay, 32 ounces of vegetable oil. It's got how many is in a bottle, maybe 11 eggs, and then water, but that's unlimited. So I mean, that doesn't really matter. Okay. So 4 boxes of cake mix, you get 4 cakes. 32 ounces of vegetable oil, 2 ounces per cake, so you have 16 cakes. 11 eggs, 3 eggs per cake, so, 1 box of cake. Alright, so 11 eggs, 3 eggs per cake, 3 cakes. It's the least amount of cakes you can make, so the eggs are your limiting reactant. Okay, so let's try an actual chemistry problem for this. Okay, so you have gaseous chlorine, react it with gaseous fluorine to make chlorine trifluoride. Okay, so balance the equation, make sure everything's good. Okay, so you are given 99.0 grams of chlorine and 99.0 grams of fluorine, and then it says that 125 grams of chlorine trifluoride were formed. So you won't need that till the end. So first you want to identify the limiting reactant. But to do this, you need to calculate the moles of reactant of reactant A and the moles of reactant B by using the grams that you're given. Okay, so what you do is you multiply 99.0 grams of chlorine times the molar, or 1 mole of chlorine over the molar mass of chlorine, which is also given in the problem. I kind of forgot to write that down earlier. So the molar mass of chlorine is 70.906, fluorine is 37.99 grams, and then chlorine trifluoride is 99.447. We will use those. Okay, so you would do 99.0 grams of chlorine divided by 70.906 grams of chlorine, and you get 1.396 moles of chlorine. We want 3 sig figs, so yeah, mark that. 99.0 grams of fluorine times 1 mole of fluorine over 37.99 grams of fluorine equals 2.605 moles of fluorine. So those are the moles that you have. Remember, 3 sig figs, so mark that. So next, you want to find out, well, first you want to write the moles up here so that you have them for later. Now, second, you want to find the limiting reactant. Again, this time you actually want to find it. So what you're going to do is use the number of moles that you're going to use the mole ratios from the balanced equation, but you're going to use the number of moles that you found in part 1 to find this. So 1.396 moles of chlorine times the moles of fluorine over moles of chlorine. It's 3 over 1, so you have 4.18 moles of fluorine needed. Remember sig figs. So then you have 2.605 moles of fluorine times moles of chlorine over moles of fluorine, which is a 1 over 3. So that's 0.8683 moles of chlorine needed. So since you have 1.396 and you have 2.605, obviously you don't have enough fluorine, which makes fluorine your limiting reactant in this problem. So for step 3, you want to find the mass of the product that is formed. You are going to do this by multiplying the initial moles of the limiting reactant by the mole ratio, and then multiplying that by the molar mass. So, and then you get the mass of the product in grams. So you have 2.605 moles of fluorine times moles of chlorine trifluoride over moles of fluorine, and then you have 99.447 grams of chlorine trifluoride per mole equals 160.5 grams, and I forgot to put the 2 over 3 here, but yeah, so we did 2.605 times 2 divided by 3 times 92.447 to get 160.5 grams of chlorine trifluoride. Remember sig figs, and that is your theoretical yield. So fourth, you want to find the percent yield. That is the actual yield that you got, during your experiment. And the theoretical yield is what you got just now, working it out. So the actual yield is given to you in the problem. It's 125 grams. You do over 160.5 grams, multiply that by 100. So you have a 77.6% yield, which is not that great. So now you want to find how much excess reactant is left over. Okay, well, in order to do that, you need to multiply the initial moles of the limiting reactant by the mole ratio of chlorine to fluorine by the molar mass of chlorine to get the mass of that reactant that you used, the excess, let's just call it that. So initial, and then you subtract the used mass from the initial mass to get the excess that's left over. So 2.605 fluorine times 1 mole of chlorine over 3 moles of chlorine times the molar mass of chlorine is 61.57 grams. And then you have 99.0 grams minus 61.57 grams equals 37.4 grams of chlorine left over. And remember your sig figs for that too. So let's summarize what we did here. So the limiting reactant, we found the excess reactant that was left over, and we did the percent yield. So your limiting reactant is fluorine. Your excess reactant was 37.4 grams of chlorine, and then your percent yield was 77.6%.